Sponsor Gravener. They're paying for your lunch today. The Gravener guys aren't here, but they're good friends of ours. They do the grooving on. If you ever want to groove a heavy vessel, they do it mechanically. It's a German company. They do pretty nice work. I like them because they make a groove that's repeatable enough that a robot can weld it. So I'm a huge fan of that. So the way it works is we're going to have our speaker talk. Josh's going to talk to us. Then afterwards, Johnny's going to have a raffle for a gift. And then after that, if you're interested, we'd be happy to give you a tour of the facility. If you find somebody with a red shirt, raise your hand. These guys, we got a lot of stuff going on right now. Offshore robots, surgical robots, building ships, building subs, all sorts of cool things. I'm going to point out Gene. Gene, stand up. Gene Robot's old friend. Tell us who you are.
I'm an old friend.
There you go.
I work for a company called YAskawa Motoman, robot company. I've been working with Dan on projects through several different of my job changes. I've been in this industry for about 20 years. Emailed Dan earlier this year and said, here's where I'm at, new company. And he said, come see me, let's talk. So we've kind of been starting a dialogue, and we're going to figure out some projects we can work on. And then he's invited us to speak today at today's First Friday event. And we're very, very thankful for that.
Welcome. So the way the robot business works, there's people that build robots like Gene's company, Motoman, YAskawa, and then there's integrators that take those robots and then tool them up and write the programs. And so there's a place for both of us in the world. So we're going to add Motoman because these guys are very good at gas metal arc welding. But enough of that. I'd like to introduce Josh Leath. And so you're going to talk about why we need to automate. I read some stats on this. We have 1/4 as many robots as Korea.
That's about right. Yep. I actually have some of those figures in.
Oh, then I'm going to let you.
You're good. Thank you, Dave. But I'm Josh Leath. I'm Senior Product Manager for YAskawa Motoman Robotics. So for Senior Product Manager, I look over all the robotic welding applications. So for us, it's what does the robot have to do to weld well? So is that software? Is that safeguarding, positioners, whatnot? So I kind of talk to customers a lot. I work with our engineering groups to decide what that is. You sure it's up? There we go. Other up. There. So today what we're going to talk about, it's as the title alluded to, why manufacturers can't survive without automation. So this is a version of a speech I gave about 2 years ago at Automate. I've updated a lot of the figures, updated a lot of the slides to be kind of relevant to today. Obviously, we're a little further out of that COVID period as we were back then. So that's kind of what we're going to talk about. So we're going to look at first current economic climate, some labor woes, broken supply chains, and a post-COVID recovery. Labor in general, so just lack of labor, looking at what labor participation looks like in our market, specifically North America and U.S. Generational gaps for skilled workers, how automation can help that, of course. Safety, so that's a big area for us with robotics. age usually. That was always floating around 55-60% historically as far as participation rate. That has dramatically dropped off at each recession, and then even after COVID, it stayed very low. So your low-cost high school labor is dramatically lower. So lots of kids focused on school, focused on sports, whatever it may be, are not in that low-cost labor, low-skill, high-turnover type jobs. Fast food, it's always kind of a stereotypical example of that. Meanwhile, your higher-cost older labor has hung on longer. So as far as retirements, there were a good deal of retirements post-COVID, as far as they never re-entered the workforce. But it's a much smaller number of workers at that point, but it's also at a much higher rate too. So what you're seeing, we'll talk about here in a moment too, is a lot of that skilled labor is holding on longer, probably because they're getting paid more, but also they kind of have to, right? So companies are incentivized to. With this slide, average hourly earnings for manufacturer employees usually floats around 2 to 4% growth year on year, but we can see on the chart that has doubled about since COVID. So this chart goes back to 85, but we see how the Fed also measures productivity. So labor productivity is your output divided by hours worked. So times, especially near recessions, our productivity seems to dive, but right now our productivity is exceptionally low as it was during COVID. So a lot of that might have been work from home situations, layoffs, people coming out of the workforce, but our productivity should be constantly in that 5 to 6 point range. But again, it's diving. So call it what it is in some sense of either lazy workers or people not achieving as much. How do you make a single worker, maybe they're just stretched too thin? How do you make a single worker more productive and potentially automation? So some of those numbers kind of wrapped up here. Our current unemployment rate as of last month, 3.9%. Manufacturing turnover rates, one of the highest, as you can imagine, in most industries, is almost 20%. So every time you train somebody, the 10 people you train, 2 of them are going to leave very soon. If you look at number of unfilled skilled manufacturing jobs by 2030, they're expecting 2.1 million unfilled. So that kind of matches some of those numbers we saw earlier. AWS always likes this figure as far as the unfilled welding positions by 2023, which is where we're at today. This is borrowed from 2021, but they were saying of this year, then we're at 370,000 unfilled welding positions. We can do that with welding robotics. And then manufacturing job openings, the last data was September, so still 647,000 manufacturing job openings. At COVID, the height of that was about 800,000. So even then, when we felt like we couldn't find anybody, this is still more than double of what it typically is at in that manufacturing space. So if there's more jobs than people, what does that mean for manufacturers? Well, production, you're probably not meeting goals, right? So I don't have enough people to meet the output, the throughput that I'm expecting. Your quality is probably going to suffer because everybody's going to be stretched a little more thin, trying to get things done, meet their targets, etc. Your turnover kind of goes with that workforce burnout too, but also your quality for high turnover is usually down because these people aren't as skilled, they haven't been in that job as long. Supply chain, I like the illustration. You're on the highway and you have that one car that taps the brake, and then everybody behind them taps their brake, so everybody kind of slows down, right? So supply chain is just that, whether it's upstream or downstream. Every time somebody taps the brakes in that supply chain, it's hurting somebody else downstream in that sense. It could even be internal. If you're trying to get something done here to there, create a bottleneck, you've created an issue for your company for those longer and longer lead times. I mentioned workforce getting burnt out if you're spread thin. So it's, how do I make somebody more productive? I work them more, right? No, you give them tools, technology, things to try to encourage more and more production. And then inflation. So we've seen this big topic. So let's look at that briefly here to explain that. So there's specific things that cause inflation that the Fed kind of keeps an eye on. So interest rates, money supply. If I cut interest rates, if I increase money supply, if I increase wages, this is what we call demand pull inflation. So a little bit of Econ 101 for you here. Demand pull inflation makes your dollar value go down. On the other side, also higher wages, devaluation of goods, increase in VAT, so tariffs from parts coming overseas, inflation expectations, just thinking there's going to be inflation, think I'm going to pay more for things, like cost push inflation. So your cost of goods are coming up. So right now we're hitting about all of these, right, in the last 3 years. So you have both things happening. You have a devaluation of currency. At the same time, you have the cost of goods going up. So what that creates is definite inflation. Mind you, I did this presentation back in 2021 before we really started to see those rates come up. But rising prices leads to rising wages, which leads to rising prices, of course, in a local economy. So that wage price spiral starts to go kind of out of control unless you can manipulate some of these pieces, which is what the Fed's trying to do, right? So trying to slow that down a little bit. And then this kind of pulls into what they call cyclical or acyclical inflation. So recurring inflation that rises from demand side of an economy, so things that are changing here. And then you also have secular inflation, which is a prolonged period of gradual price increases. So how many have had a supplier where every time you get that price list, it's a little bit more. You don't know why. Well, it's a lot of factors why for them. You know, they had to hire more people. They had to buy more trucks. They had to take out new loans so that price points from their price list go up a little bit over time. So you get that cost creep. So even though that cost creep could be pointed to at some of these, it's a separate type of inflation that economists like to measure as well. So all in all, saying we're in a bad spot right now for inflation to continue to rise. It's not going to slow back down to sub 2% anytime in the next coming years. So this is of no surprise, but supply chain, you know, what are some of the things we hear a lot about? Chip shortages. This is starting to level out a little bit. Ohio, we're getting a great big chip factory here in a couple of years, so that might help out with that. Shipping costs have been rising. Like everything that goes up, typically it doesn't come back down to where it was. It might kind of crawl off a little bit, which is what we've seen with shipping prices, but they're not back down to where they were pre-COVID. Labor shortages, no surprise there. We've talked about that. There's container backups there for a while, so we're still getting caught up in a lot of issues there. But again, with a lot of these cut-ups, now we're facing an almost opposite type situation where total business inventories in 2001, see that recession, 2008, went back down, of course. We climbed over time. COVID hit, we were down, we had shortage of inventories. Right now, inventories are extremely high because we've kind of hit this whiplash point. So with more onshoring, we could have controlled this a little more through automation, making people more productive through technology tools. Looking at GDP, so you keep hearing the recession word the last couple of years, right? So are we in a recession? Is there going to be a recession next quarter? No. We've well avoided any recessionary. If you look at GDP on the blue line here, it started to come down a little bit post-COVID. We never went below that 0% threshold to say that we declined in growth for that quarter. So we have never hit a recessionary period. In fact, it's heading back up. At the same time, imports, you can kind of see after every recessionary period, imports kind of dive and then spring back up. We're starting to see that right now too. We are thinking we're heading into recession, imports dive, but they're going to spring back up. So what we should be doing for higher GDP, we make up with in imports, essentially, in that respect. But then this last one is our, I'm calling it a deficit. It's actually the net trade here, but your trade deficit between what we're buying and what we're selling as far as imports and exports, that deficit's still huge. So there's still, every time that's below zero, that means we're buying more to bring into the country than what we are selling. So all of this is opportunity for manufacturing in the United States. Looking at generational skills gap, majority of the trade skills, of course, exist in baby boomers and Gen X. I tell people, somebody just said this a little bit ago too, but it's easier to train a welder to program a robot than to train a robot programmer to make a robot weld. So if I'm training the robot to do something right, by golly, I better know what I'm doing to make the robot repeat that, right? If I don't know how to weld, I'm going to give it a crappy weld. The robot's just going to repeat crappy welds every time. So you still need skilled labor when it comes to training robotics. Right now, millennials are over half of the entire workforce. The entire millennial generation is within that employable age range. But they didn't train for this. They were extremely focused on college. At the time, I believe it was over 73% said that they felt pressure to go to a college and they felt that that's what they had to do. Compared to now, Gen Z is saying, 74% skills-based education makes sense and only 51% are interested in choosing a college degree. So where we kind of hit, again, this whiplash of go to college, be a lawyer, be a doctor, as we were talking before. Now that's not necessarily the case. Find skills-based things, even programming. There's certificate courses now that you don't have to get a college degree just to learn how to do a specific type of programming or accounting, for example. But the one thing, as far as with all of Gen Z and most generations, it's all money-driven, right? So either I don't want to go in debt or I want to make the most potential money. It's not like money's tied to a college degree and that's the way I'm going to be successful in life. It's, no, I have interest in skills and I'm going to come away with far less debt than what would have been the case several years ago. So that was all kind of labor force and where we're at with the labor side of things. Now, if we look at safety, this is a smaller section here, but the 3Ds are typically what we say we want to look at for automation. So dull, dirty, dangerous. Lately, you've also probably heard DEAR, so delicate operations that might have not fit in dull, dirty, or dangerous. It's just hard for a human being, laser-type precision stuff. So dull, the job's uninteresting. It's difficult to retain talent for that job. Dirty, job's not in a comfortable working area, so it's kind of a little bit of both of the dull and dangerous. Might not be safe. I just don't like going home every day smelling like fry grease or whatever it might be. And then dangerous, that job has inherited risks. With welding, I can hit all these, which makes it very easy to automate welding and justify automating welding, right? If I'm doing the same seam over and over 500 times a day, that's pretty boring. Dirty, I'm getting a lot of smoke in my face, a lot of spatter on my clothes, whatnot. Dangerous, I got arc flash, I got high voltage things to worry about. But if you look at workplace injuries, this is some of the data from Liberty Mutual. And what OSHA is having to pay out, thus what's costing employers for different types of workplace injuries. Leading is over-exertion involving, outside sources. So anything that's related to lifting, pushing, holding, handling, palletizing, etc. That's where most of those injuries are happening. Somebody who falls, if they're struck by an object, other exertions, body reactions, a lot of things that happen around heavy metal, of course, in our manufacturing space for welding, but just redundant type ergonomic issues that are causing injuries. So again, something that's easily replaced with automation. For example, welding fumes. This is one that's kind of snuck up the last few years that OSHA is really starting to crack down on. Some states have already focused on this. Obviously, California always kind of leads any of those safety concerns, eco concerns, whatnot. But in welding fumes alone, there's 22 primary dangerous fumes found frequently in welding. So that's carbon monoxide, lead, phosphine, nickel, beryllium, chromium, lots of carcinogens, poisonous type smokes there that if I'm a welder and I want to outfit right for that, I have to wear the hood with backpack, etc. That's not an ideal working environment. So if there's something I can have a robot do and I can just capture those fumes at the source, I will certainly want to do so. So looking at robot automation, who is automating? First, just kind of take a step back to clarify what is automation. Using any reliable technology to minimize human input on repeatable tasks to increase productivity, reliability, and efficiency. Typically, we just call this technology, right? Many degrees and methods of automation, but again, ideal for those dull, dirty, and dangerous. So the types of automation you'll typically see when you hear the term automation used from an industrial point. Part of that is industrial arms. That's what we specialize in. That's what Dan's very used to putting in place here. So welding, palletizing, painting, anything that arm can do repeatably well over and over again. Part automation is kind of the other step of that as far as CNC machines. It's not a 6-DOF arm, as we call it, 6-degree freedom arm, but it might be something that's very specialty for filling bottles and capping on, or CNC machines, etc. The rest of this is mostly as far as data-based, so whether it's data automation itself, warehouse automation, so the AGVs trying to find stuff, trying to do simplified planning in a warehouse type application, or doing the same thing for transport, so interstate type cargo. This is a McKinsey study. If you ever want a lot of good information for automation data, McKinsey does a great job. They don't charge for the majority of their just general reports as well, but they're one of my favorite sources. So they had a study, it made a big splash a few years ago when it came out. I think the initial one came out like 2018, 2019, like you said. In the next, what was it? Next 15 years, there's going to be a 31% decline in labor for things like food preparation, mechanics, manufacturing, protective services, cleaning equipment, and machinists, all of which can be automated, which sounds really scary, but at the same time, later in the study, they said by 2050, 30% of the jobs that are going to exist in 2050 don't exist today. Job titles that do not exist today. Just like what you might have had somebody that specialized in AI learning today, that didn't exist 20 years ago like it does today. So those different markets will change over time, none of which put people out of employment, but force you to also look for other opportunities for, how am I advancing my product and community from that respect. So looking at benefits of automation as a whole, we've kind of touched on a lot of these before, but you're reducing your dependency on labor. I'm reducing manufacturing costs, so as far as if I can do something faster with better throughput, less waste, I'm reducing the cost of those goods. I'm improving the worker safety and quality of life, because I can possibly retrain them to do other value-add jobs instead of just doing the same weld button over and over again. I'm increasing quality and consistency of my product, so my customers are very happy. It's all recordable and traceable data, so I can say, this is good, how do I make it better, right? If I'm putting out this many parts today, and I'm using these different processes, if I change that, is it better, is it worse? And then mitigate fluctuations in cost, market ebb and flow, as we were looking at on some of those other slides. So another brief lesson 101 manufacturing, there's 4 factors of production. These are kind of your limited factors, right? So land, that's pretty self-explainable, but location base, the building that we have right here, the fuel, the energy that it takes to run that, the labor, so the people that are here actually creating economic value, that's my GDP, that's my product that I'm creating. That's pay, the pay is typically based on skills, so low skill, low pay, high skill, high pay. Capital, money to drive all that, and entrepreneurship, willing to drive all that. So those are my limited resources. Well, if those are limited, how do I expand those further? And then that's what your total factor, as they call it, productivity boost is going to be that technical side. So that technology that you add into it, robotics in this case, is going to help drive the efficiency of all of that. So who is automating? This was an article back from 2021 in The Economist called Automatic for the People, talking about China, of course. Economic growth depends on just 3 basic factors, as we said. How many people are working, how much capital they have at their disposal, and how productive they are. So if you look at Chinese robot adoption from their article here, you can see as far as they have a huge robot adoption, annual robot installations. I'll compare this against other countries here in a moment. But also their wages have gone up over time. Why? Because they can produce more. Those people are going to have higher value jobs. But at the same time, a lot of these robots being used in China aren't for exports anymore. China finally has a middle class, right? These people that they've been giving us all of our gadgets and gizmos over time, they're starting to want those for themselves. So with that demand, they've actually been able to increase their wages as they increase automation quite dramatically. So the rest of the world, just 10 years ago, 11 years ago, in 2012, China was only 14% of new robot installations. China is now 52%. That number's grown again this year in 2023. I guarantee you'll see that probably 54, 55%. The countries with the highest density, though, and this is what we were talking about with the Korea piece here, Korea's always been the highest. So lots of electronics manufacturing assembly that's happening in Korea. Per employees, they have a much larger degree of automation there. Everybody looks down at their phone. Half of them are going to be Samsung. Those are all coming out of Korea. Look at your appliances at home. If it's Whirlpool or Maytag, it's here. Just about everything else is coming out of Korea, right? So as far as a very large degree of manufacturing electronics happening there.
You have a question?
Yeah.
So short and skinny on this slide. So for every 10,000 employees that a company has, or like a country has,
Yep.
it has, South Korea has 1,000 robots, 1 in 10.
Yes. That, how dramatically that's changed since 2017, albeit this is a year and a half old now, though. It hasn't stayed the same, right? Even as their population of workers grows, robots are growing even faster. And South Korea is also a very rich country, too, as you mentioned, too, because of the GDP that they're putting out for that level of efficiency. Similar for China, we've seen good growth, Japan and Germany, good growth over that time. But China, again, they've more than threefold what China's got a lot of people, right? So threefold as far as what the robot density looks like. A little bit of growth in the US, a little bit of growth through some of our other countries there. So this is that annual installation of robots comparing Asia, Europe, and the Americas. Again, we're all within spitting distance here, 2012, 10 years ago. Now Asia, so Asia would include China, Korea, Japan, has far out automated us in that sense for total units installed. If you look at who's installing them, what industries, so electronics, again, Korea in that sense, China, Japan, a lot of that focus on electronics. Automotive has always been #1 in the US. And this is comparing 2020, 2021, 2022 with the gray, red, and blue bands there. So automotive continues to grow, even though it's slowed down a little bit for us that we've seen lately. But again, globally is what's pushing that number up. And then areas that aren't as automated. So food, plastic chemicals, metal machinery. I was here to say, of any of these industries that has potential for growth, now it doesn't affect a lot of us here in the room, but food is #1. Food, if you were to fully automate that from the production factory side to even your food service side, is far and away larger than automotive or energy. So that's all of your restaurants that are local to you, back-end kitchens, maybe serving the factory side of it from frozen waffles, pancakes, etc. Food could eclipse all of these easily. It's a far under automated area. So again, installations by application. So what's the robot actually doing? It's not in the electronics industry, it's handling something in the electronics industry. So handling's #1. Welding's fallen off a little bit. It's pretty flat every year, but we're seeing the best growth out of handling. And then dispensing, because it's primarily a small market. So dispensing is any type of adhesive, coatings, paints, etc. And then if you look at, again, automotive has always been in the lead as far as what general industry looks like outside of electronics. So in Germany, automotive is huge against everything else, as is in the United States, Japan, and China. And so most of those installations going into automotive factories. So again, everybody else has that opportunity. I can tell you our largest area of growth has been general industry. I'm sure Dan will probably agree with that here too, as far as general industries finally catching up to what automotive has been doing since the late 80s. For current users, main trigger for why do I want a robot? It's pretty obvious. #1 is reduce cost. This is out of that McKinsey report as well. Improve quality, so I want to improve the quality of my goods. Increase productivity through R&A, improve the capabilities of robots, enable higher flexibility in production. So your first few here are, improve my product, improve my price. Everything else is, improve safety, unburden my employees, add flexibility in production. So things that, especially in those, what kind of hurt us there in COVID for supply chain and whatnot, adding flexibility, adding a good environment to work in, etc. So if we look at just specifically to welding, a robot welder, typically, and this is kind of rough numbers I've worked up here, it's going to cost about $25 an hour for the first 4 years. I believe I base this on 2 shifts a day, kind of basic production, but about $8 an hour thereafter. Human welder, these are very conservative numbers. $13 to $17 for basic, $25 to $30 for skilled. That's for the life of that welder. That's only going to go up because of inflationary figures and then what labor continues to cost. So we've created this thing, not a salesy thing. If you go here and check this out, it's not going to sign you up on any lists or anything, but just kind of a cool tool. It's a payback calculator, so you can actually say how many welders do I have per shift. In this case, 4. How many shifts per day? 1. What's the cost? So salary plus benefits plus anything else for them. $60,000. Future, so after I integrate robots, all right, those guys I'm going to repurpose elsewhere. I'm going to have 2 operators there. So I'm only replacing per se 2 on that system, on that part I'm making. And what's my target payback? 18 months is very typical from what we hear from customers. So based on that, to get 18 months, your system budget's about I think it's 180 grand. very doable for a basic robot system, especially if it's doing fairly basic parts at that rate. So you'd still need your two operators, or just be a single robot, and this kind of shows you what your cash flow is over that time. So over 10 years, you're netting about $7.3 million versus what it was costing you before with those humans. And then, more than that, if those humans then are doing more value-added work, drumming up more business for you, for example. So companies know this. Automation is booming. There's lots of different types of robots, from security to production to manufacturing. So we're seeing automation increase quite a bit, which is good. But the weird thing is it's still not fast enough. So, Stockton and next one here. So this was a Reuters report. Robot apocalypse is hard to find in America's small and medium-sized factories. So SMEs are far underutilizing automation. This is what's going to hurt SMEs if they don't. So the quote from the Reuters, this is bad news for the U.S. economy. Automation is a key to boosting productivity, which keeps U.S. operations competitive. Since 2005, U.S. labor productivity has grown at an average rate of only 1.3%, well below the post-World War II trend of well over 2%. And the average has dipped even more since 2010, as we saw again since 2020. And this was just a piece from that. I won't read all this, but basically a guy saying, yeah, it's a small, medium enterprise. I got a big contract from Tesla. They told me I had to have robots to make this part. I bought robots. A couple years later, then Tesla pulled back on their contract. What do I do? He's not worried about it because he has the flexibility of a robot now. He can manufacture whatever he wants. So he said, we found another part to make on the machine. And he was happy. He was extremely profitable and kind of moved on with life. So it's not one of those things to say, well, if I'm only going to buy a robot for this one part that I'm doing for one customer or a variety of customers, I can retool that machine and repurpose it and not have to worry about in the same sense that where I lost an employee or had to fire an employee because we lost a contract. So it's a much more flexible type manufacturing situation. A couple slides to wrap this up here. So how to automate, identify those processes, work with an integrator such as ARC Specialties to determine the best method of how to get there, but then prioritize your areas of automation. So typically it's going to be payback, where my bottlenecks, quality, but there's a lot of good whys. So increasing quality like what we saw before, reducing scrap, reducing labor turnover, reducing costs, increasing flexibility, et cetera. And then focus on that. Make that your priority of this is why I'm automating. If it's saving money, it's saving money. And this is what the integrator is going to help you do to get there. And then for redistribution of human capital, I mentioned before, McKinsey said that's not a worry in their studies because there's so many more roles growing at the pace of the stuff that should be automated is being automated, but more service-oriented roles, so maybe people to build relationships with customers, vendors, create a better customer experience, whether that's through marketing, through more of a hands-on listening side. I use the example here, if you had Chick-fil-A is kind of at least where I'm at in Ohio, I assume the same here in the South, it's kind of, your best of best when it comes to service, right? You go there, somebody's going to be happy to greet you. There's always going to be somebody at your table checking, see if you need anything, even though it's a fast food joint. Well, if every McDonald's, Taco Bell, Burger King could invest in more automation in the back, get those people up front to improve a better service environment, that's going to be better for the entire company. So the same thing on the manufacturing side, more feet on the street, creating relationships to improve that. Also rising incomes and consumption with the redistribution of human capital because you're producing more. There's an who's the economist? It's not gonna come to me, but he used to say there's, with enough automation, we could hit a 15-hour work week. Obviously, that's probably not realistic, but you could automate enough, still produce enough, and be able to pull back on that. So it's basically maybe less overtime for folks, but you can still pay them just as much because they're not stressed on that. You're still hitting your production values. So these are just examples of roles that are growing over the next 15 years. So unpredictable labor, so repair, emergency, installation, transportation. Teachers are growing, professionals, they expect to grow, so account managers, engineers, managers and executives, different decision makers, care providers, so doctors, nurses, et cetera. Technology professionals will continue to grow, they didn't give a rate, and builders and construction are expecting to explode over the next decade. So all in all, the world is changing and adopting automation. If we in the US or your company are resistant to change, we will fall behind. We're already falling behind. I kind of use this analogy here. If you have an employee that wasn't willing to learn something new to be more resourceful, how would you react? So that's how our customers are going to react, right? So if we're not willing to make up production numbers, improve our quality, we're probably going to get fired as a company or a manufacturer from helping them on their part or for our end users. So it's kind of the same thing. It's necessary. I don't call it evil in that. It's a necessary tool, technology that will actually help you get ahead, but also survive at the end, right? So if everybody else around you is automating, you have to automate. And I kind of hit this before, but how do I know it's ready to be automated? It can be automated, so usually repeatable. Labor's hard to find, workplace needs improvement, market for your product is highly competitive because I'm competing with other companies and countries, and payback time is achieved. So what we kind of hit on today, any questions on it? Yes?
What does your robot look like?
Say again?
What does your robot look like?
Our robot?
Yeah.
It's blue. It's supposed to be salesy, so I didn't show it.
Okay.
You had one picture on there, I think, didn't you?
There's a FedEx one that came up, I think. That had on there, so. Yeah.
So how do you think AI can learn, can be in robots?
Right. So YAskawa actually, this will be my slide series.
That's okay.
Just because it's cool.
You did good.
So YAskawa this week is launching a controller at IREX. So IREX is the largest robot show in the world. This robot controller has an ACU, so basically a hyperprocessor in it that can do a little bit more on the machine learning side. The idea being that this controller and then this actual articulated arm can learn from tasks rather than repeatable programming. So typically, if I'm going to teach a robot, it's doing the same thing over and over and over. So if I'm picking up part A and moving it to location B over and over, that has to be repeatable. If part A changes in size, that changes. If location B changes in location, all that changes. So if I have a task that with kind of the brain of this, that I train it over time to say, look for the open spots, that's what it's learning in that respect. So that's what this new robot controller will be able to do. Inspection is a big area that we expect to expand with this. So if I say, this is what a bad weld looks like, this is what a bad weld looks like, this is what a bad weld looks like, this is what a good weld looks like, this is what a good weld, it'll pick up those differences over time. We're actually doing something with IBM on that right now with just while I'm welding, looking at that weld puddle and listening to the weld, I can come up with a score to say that should be a good weld or that should be a bad weld. And be able to use that data to say, go inspect that part, but these 30 are okay.
So if you have a robot and you tell the robot, well, go mop the floor.
Right.
So you don't have to say, well, the floor is 10 by 8, and you don't have
Right,
to,
sure.
It just knows what to do, right?
That's kind of like your Roombas, right? So the Roomba, all it knows is to keep moving around this room cleaning until it reaches the end. Now, for what the robot is, you can't just throw an articulated arm at that because the articulated arm needs to go around the room, right? So could you put on an AGV? Maybe, I could do that. $60,000 versus a Roomba that's $500, right? So there's different kind of levels from that standard automation. Sam's Club, though, they are doing that mopping robot. If you've been to a Sam's Club lately, it just looks like a giant Roomba. It just goes around the store. It senses when somebody's nearby and it stops. And then if there's something on the floor, it sends an alarm for somebody to come pick it up. So, kind of cool. I'll leave a few cards up here, too. If anybody has any questions about this in general, whatever, let me know. I'm happy to help. Thank you, Dan.